Let's evaluate the integral of x squared e to the negative 3x by using integration by parts. Recall that the integral of e to the ax is equal to 1 over a e to the ax plus c for any a not equal to 0. And we're going to need that toward the end of this problem. Integration by parts uses the following formula. The integral of u dv is equal to u times v minus the integral of v du. We let the difficult integral be the integral of u dv. From there, we'll label one of the parts u, the other dv, find du, find v, and express it in terms of the right-hand side, particularly the integral on the right, and hope that that integral will be easier to evaluate than the original integral. In our case, we have the integral of x squared e to the negative 3x. The rule of thumb when we have an exponential and use integration by parts is always let dv be the exponential part of the integral. So in this case, it's e to the negative 3x dx, and there it leaves x squared for u. Du becomes 2x dx, and v is the antiderivative of e to the negative 3x. It's like a equals minus 3 in the formula above, so it's minus 1 over 3 e to the negative 3x. We don't have to add a constant to it. 0 is perfectly okay. It makes things much easier. So the integral in question, x squared e to the negative 3x, is what we call the integral of u dv. Now let's express it using the right-hand side of the formula. U times v would be minus 1/3 x squared e to the negative 3x minus the integral of v du. Notice that v has a minus in it. That will make that minus into a plus. 2 times 1/3, that gives us 2/3 times the integral of x e to the negative 3x. Now the integral on the right, this right here, is u times v, and this, all of this, is the integral of v du. The integral on the right, the integral of v du, should be easier, and you can see it's not perfect. We can't solve it immediately, but at least it's a little bit easier in that the power of x is now decreased from 2 to 1. Now I'm going to use integration by parts again, but only on the integral without the 2/3. We'll come back and multiply the answer by 2/3 as a last step. So here is the integral of x e to the negative 3x. We'll use integration by parts one more time. U is going to be x, du will be 1 dx. V once again, or dv once again, is going to be e to the negative 3x dx. And so v will be minus 1/3 e to the negative 3x once again. So this integral is u times v minus 1 over 3x e to the negative 3x minus the integral of v du, but this has a minus, so this will be plus 1/3. The integral of v du is just e to the negative 3x, and this integral is easy. We can do it using the formula above. So this is minus 1/3 x e to the negative 3x minus 1/9 e to the negative 3x. Let's return back to the original problem. The original problem is right there. So we have the integral of x squared e to the negative 3x dx. It was equal to minus 1/3 x squared e to the negative 3x plus 2/3 times the integral of x e to the negative 3x. We just evaluated that integral, so the answer is right there. So we put minus 1/3 x e to the negative 3x minus 1/9 e to the negative 3x. Once all the integration is done, we can then add a c at the very end. All we have to do is just simplify it just a little bit. The final answer is going to be minus 1/3 x squared e to the negative 3x minus 2 divided by 9 x e to the negative 3x, and then minus 2 over 27 e to the negative 3x plus c. Now we could factor e to the negative 3x, possibly even 1/3, but this is perfectly okay to answer in this form.